Okay, so what I've done to make this video easier, I've taken screenshots of all of the solutions, and then, so make sure you've done the problems that you need to first, and then go ahead and check your answers, and if you need to fast forward to actually watch the solution, how I've worked any of them out, do that once you've figured out which ones you need to watch. I would try your best not to watch the whole thing because, oh my gosh, that's going to take a long time. So here's the first set, 1 through 4. Or 5. I guess we already talked about 5 and 6 in class, so I'm not going to spend time on those. Here's 7 through 10, 11 through 14, 15 and 16, 17 and 18, 19 through 24, 25 through 28, 29 through 33. So like I said, the rest of this video will just be me explaining each one of those problems. All right, so we're going to dig right into solving these problems. The first thing we're going to do is make all the visitors go away, which includes this -1 and +10. So if I do that first, I'm going to have 6 plus m, let's see, absolute value, subtract 10 from both sides. It's going to be less than or equal to -2. Then I'm going to divide by -1, which is going to flip my symbol around. So absolute value of 6 plus m is going to be greater than or equal to +2. So now we are ready to set into our two cases. We have 6 plus m is going to be greater than or equal to 2. Since this is more, this is or. And then we want to flip that around for the other case. 6 plus m is less than or equal to -2. I'm going to subtract 6 from both sides. M is greater than or equal to -4. Subtract 6. M is less than or equal to -8. And then or means they should be going opposite directions. So when you graph what you just solved, you should get arrows going in opposite directions. So greater than or equal to 4 is going to be closed and to the right. And then less than or equal to -8 is going to be closed and to the left here. All right, question 2. Again, we're going to get rid of our visitors first. So I'm going to subtract 8 from both sides. It's going to give me 3. M over 4 is less than or equal to 6 when I subtract 8. Divide by 3. M over 4 absolute value is less than 2. So now we're ready to split into our two cases. We've got M over 4 is less than 2. And since this less than, this is and. That means our range should be within. M over 4 is greater than -2. Then I'm going to multiply by 4 to get m by itself. So m is less than 8 and m is greater than -8. And so and they should be going towards one another. So we've got open greater than -8, open on the +8, less than +8. So we're really just looking at this section in between for and. We're looking for the within section. Question 3. All right, so remember, we've got to get rid of visitors first, and we cannot combine these two right away. We're going to have to take care of each one of them separately. So I'm going to subtract 1 first. Remember, you have to do the multiplication or division at the end. So subtract 1, that's going to give me 2, 6p plus 8 is greater than 32. And then divide by 2, 6p plus 8, and the absolute value is greater than 16. And now I'm ready to make my two cases. 6p plus 8 is greater than 16. And this is more, so this is or. 6p plus 8 is less than -16. All right, and then if I just solve each of these out, I'm going to get those two answers. And remember, or, they should be going apart from each other. So if I've done everything correctly, they will. So this is less than -4, open and to the left. Greater than 4/3, which is just a little bit bigger than 1. Open and to the right. So I know that what I've solved seems pretty good. All right, so if we check question number 4 now. Okay, so same thing, going to subtract 10 from each side first. 7 plus r, less than or equal to 24. All right, divide by 2. 7 plus r absolute value is less than or equal to 12. So we're going to set up our two cases. Either 7 plus r is less than or equal to 12, and it's less than, so that's and. 7 plus r is greater than or equal to negative 12. All right, and then if we solve this out, we're going to get r is less than or equal to 5, and r is greater than or equal to negative 19. And means these two should be going towards one another. This is kind of a within problem. So negative 19, notice this is negative 16, negative 20, that's negative 18. So negative 19 is actually in between the last two markers. So it's going to be closed and greater than. And I want less than or equal to positive 5, which is going to be right here. Less than. So we're just looking for that middle section right there. All right, so we're going to change to vertex form by completing the square. You all were good at this when we did it the first time. You just forgotten it because it's been a little while since we looked at this. So we're going to divide by a GCF. Well, first we rewrite it. 24x plus blank or minus blank, however you want to write that. Now we're going to take a GCF out. That's going to give me x squared minus 12x plus blank. Take half. So that's going to give me x minus 6 squared. I'm going to go ahead and bring this GCF down. That's going to give me negative 2. And then I want to square that 6 squared. So that's going to give me 36. And then remember this is distributing. So 2 times 36, negative 2 times 36 is really negative 72. Now, normally, this last number that they give us is wrong, and we have to fix it. But negative 72 is exactly what they told us we should get, so we don't need to add or subtract any number like out here at the end. If it makes you feel better and you want to write like plus 0, you can, but you don't have to. So the final answer here, the simplest way to write the final answer is going to be y equals negative 2, x minus 6 squared. All right, let's check question 8. So same way, we're going to take out a GCF, or sorry, copy it with a blank first, plus 24x plus blank. Take out a GCF, negative 2x squared minus 12x plus blank. So it became minus 12 because I'm dividing by negative 2. Take half, x minus 6 squared. Bring the negative 2 down. Negative 6 squared is positive 36 times negative 2 is negative 72. So I have negative 72, but I need to get back to negative 80, so that's going to be minus 8. So there's my formula, y equals. There you go. All right. Question 9 and 10 are both really easy. It just says identify the y-intercept, and in standard form, the y-intercept is this last part, so that's all you really have to say. If you wanted to be really fancy, you could write it as an ordered pair, 0, negative 15 over 2. And this time I'm writing the y value, like it's a y-intercept, so the value is going to go in the y spot instead of the x spot like we normally do with roots. All right, and then question 10, the y-intercept, hanging out here it is. Make sure that if you circle it or whatever you do, you identify the sign that goes with it. So this is negative 1,108 for the y-intercept. All right, I'm really trying not to lose my voice, so I'm going to try my best to make it through this. This is in vertex forms. The first thing we want to do is name the vertex. Inside's the opposite, outside's the same. And then we know the 2 out there is going to be a vertical stretch of 2. So that's going to, for my 1, 3, 5, 7 over 1 vertical is rise. That's going to change this top set by 2. So I'm going to start at 3, negative 6. Instead of rising 1, I'm going to rise 2, run 1, rise 6, 1, 2, 3, 4, 5, 6, run 1. And if I had room, I'd rise 10 next, 2, 1. I think you all are feeling much better about this part than when we had first done this last week. All right, and then domain and range. Domain is always going to be all real numbers, and it will be for a while for us. Range, the lowest value here is negative 6, and the highest value is positive infinity. All right, question 12, very similar. We're going to name the vertex first. So obviously they've already graphed this one for us, but we know how to write it out. Vertex is going to be 2, negative 4. Inside's the opposite, outside's the same. So we've plotted that, 2, negative 4. This 1/3 is a horizontal. It's on the inside, so that flips horizontal, and it becomes a stretch. So that means for the 1,357 over 1, we're changing this run part because horizontal is a run component. So I'm still going to go up 1, but instead of running 1, I'm going to run 3. So up 1, run 3, up 3, run 3. Same thing on the other side. Up 1, run 3, up 3, run 3, and then we would go up 5, run 3. So that's how they're getting this shape. Okay, question 13. Graph each equation and state the domain and range. So this is just an exercise in doing what you did before, changing this over to vertex form. Notice you can already find the y-intercept if you just want to check that what you're doing is right. So I know this should intercept at 7. And then I'm going to just go ahead and complete the square on this one. So x squared minus 6x plus blank, that's going to give me x minus 3. Squared, so that is 9, and I need to fix that. 9 to 7 is minus 2, so that's going to put my vertex at 3, positive 3, negative 2. Remember, inside's opposite, outside's the same, so 3, negative 2. And then this just has a 1 in the front, so no vertical stretch or horizontal stretch or compression, so this is just 1,357 over 1, so up 1 over 1, up 3 over 1, up 5 over 1, and notice that does verify that I have the correct y-intercept, so I know that this is done correctly. All right, question 14, really similar. We're going to go ahead and set this up. So negative 2x squared minus 12x plus blank. I'm going to factor out a negative 2x squared minus, plus 6x plus blank. So negative 12 divided by negative 2 became positive 6. And then I'm going to take half. That's going to give me x plus 3 squared. Bring down the negative 2. So plus 3 squared is 9. That's really negative 18, which is what they said it should be. So if you want to write a plus 0 at the end, you can, but you don't have to. So my vertex is going to be negative 3, 0. Negative 3, 0. And then notice here I've got a reflection, that's the negative part, and this is going to be a vertical stretch. So for my 1,357 over 1, I'm going to multiply this top set by negative 2. So I'm going to be going down 2 to the right and left 1, and then down 6 to the right and left 1, and that'll be all I can fit on this part. All right. Okay, so identifying the transformations, this is just where we list shifts, reflections, stretches, or compressions. So you all are pretty good at the vertex part. No, I draw arrows to all of these things so I remember how many things I have to list. So any of these, the numbers are very obvious. Don't forget that this negative in the front is going to have its own thing to list. So if I go ahead and name what all these for, the negative 3 is going to be opposite, so that's going to be a shift right 3. Outside is the same, so that 6 is going to make me shift up 6. The 2 right here out in the front is going to be a vertical because we're on the outside. You're nodding your head up and down, so that's a vertical, which means it keeps the same, so this is going to be a stretch. So vertical stretch of 2, and then the negative is going to be a reflection over, think about, you're nodding your head up and down, so you're flipping over the x-axis because you're flipping in the vertical direction, up and down. All right, and then on question 16, if we look here, we're going to name all these. So this positive 9 on the inside is going to be a left 9. Plus 9 on the outside is going to be up 9, and the 4 on the inside, so we're on the inside, which means left to right, so we're talking about horizontal. We want to be opposite, so instead of fourth, that's 1/4, and that, now that that's a fraction, that's going to be a compression, so that's going to be a horizontal compression of 1/4. All right, here's our in behavior questions. This is from that first week. So you all did good. We say what is happening on the end, so this is going left and down. This one is going right and up. And so when we go to name that, remember x goes to the negative infinity, that's left, And so left is going down, so this is going to be negative infinity. And then x going to positive infinity, that's right. So that's right and up, so f of x is going to positive infinity. You kind of think about putting in behavior in the same order. Some of you were getting that backwards last time. Think about it as putting it in the same order as you would write like an ordered pair. Like ordered pair, you do like x comma y. So you should do your x direction first and then your y direction when you're talking about in behavior. All right, question 18, really similar here. Here I've got left, and some people say this is up, but notice this is kind of leveling out at that 4. So it's not actually going up forever, it's going to 4. And then on this other side, we've got down. What am I saying? I mean, it is down, but we should do the right, left and right part first. So this is right and down. So now if we name our in behavior, x to negative infinity is to the left, so that one's going to 4. And then x to positive infinity is right, and that is going down, so we're going to write negative infinity. All right, woohoo, factoring. So factor, remember that just means my final answer should look like it's in this factored form. X plus something, maybe x minus something, maybe 2x minus something, but my answer is going to be in parentheses like that. All right, so that's going to be my puzzle. So this is negative 32, negative 4. My two numbers should be negative 8 and positive 4, which is going to give me factors of x minus 8 and x plus 4. And since this is just telling me to factor, I should be done there. Question 20. If you can take out a GCF, you always should. Otherwise, your numbers are going to get really large and you're going to lose numbers in different places. So I'm going to take a 2 out. That's going to give me the equation x squared plus 12x plus 35. Much easier to work with. So now my top number is 35. My bottom number is 12. All right, and then my two numbers that are going to multiply, I think that's going to give me 5 and 7. So my factors are x plus 7, x plus 5, and we don't want to forget to bring this GCF down here in the front. Okay, question 21. Some of you worked this out like you knew the back part was missing, so you put a plus 0 at the end. That's fine, you can do that. There's not a GCF, so you'd multiply, you'd get 0 at the top. This is a long way to do this problem in my opinion, but I'm going to show you this way just so we stay in the same rhythm. Negative 3, two numbers that multiply to 0 and add to give you negative 3, or negative 3 and 0. All right, so since we moved the 5, we're going to do x minus 3 over 5. X plus 0 over 5. If it divides, divide it, so this is going to be x plus 0. If it doesn't, bottoms up, so this is going to be 5x minus 3. And another way to write x plus 0 is just to write x. So another form of this would be x 5x minus 3. Now, some of you may have noticed that you can get there sooner by recognizing that since this is all the problem that they give us, we can identify the GCF in this case as x. You can't do this when you're completing the square, just when you're factoring. But if you divide the x out, like you're going ahead and being left with 5x minus 3, which there is nothing to factor there because the x's are already having like singular exponent values. There's no x squared left anymore. So that's another way to do it if you can kind of follow that method. Up to you, whichever one makes more sense to you. All right, question 22. Unfortunately, this does not have a GCF, and 5 itself is not a perfect square, so I can't split it apart in that like shortcut way. So I'm going to have to move the 5 to the end. That's going to give me 80 on the top, negative 42 on the bottom. Let's see, that's going to give me negative 40 and negative 2 as my numbers. So make sure you use that 5 again. So we're going to do n minus 40 over 5. N minus 2 over 5. If it divides, divide it, so n minus 8. If it doesn't or doesn't simplify, we're going to do bottoms up, so this becomes 5n minus 2 as my factors. All right, question 23. Again, no GCF that I can plot out all three of them, and 8 is not a perfect square, so I can't break it down that way. So I'm going to move the 8 to the end, negative 32. I tried to tell some of you, if you notice these two numbers right here are really close to one another, that probably 1 or -1 is one of the numbers that you're trying to pick from. So here we're going to be getting, let's see, -32 and +1. So that's going to make my factors p minus 32 over 8 and p plus 1 over 8. I'm putting the over 8 because I moved it. Don't forget that. Divide if you can, so that gave me p minus 4. If you can't, bottoms up, so 8p plus 1. That's my factor set. Last question. Okay, so the first time I did this problem, I did not realize there was a GCF, and I multiplied, and I got monstrous numbers that were going to be way too difficult to deal with. So now the GCF is not 18, but there is something you can divide into all three of these, and that's 3. So if you go ahead and take your GCF of 3 out, that's going to leave you with 6v squared minus 11v minus 72. Now that's still not great because 6 times 72 is going to be big, but not too unimaginable. So we're going to have -432 over -11. So hopefully, if nothing else, you realize to take the GCF out and you're here watching this problem because you saw -432 and you wanted to cry about it. All right, luckily it was much quicker for me to find the two numbers this time. So the two numbers are going to be -27 and 16. This number is huge, so I'm not necessarily asking you to find those two numbers with something quite this large on your test tomorrow. But if you know those two numbers, you may want to pause now and see if you can work ahead of me and then just check to make sure that you're right. Okay, so I'm going to go ahead and set this up. V minus 27 over 6. We're going to do v plus 16 over 6 because that was moved. I should have drawn that. Also don't forget that GCF out there in the front if you need to carry it the whole time to not lose it. Now notice that neither of these divide exactly, and we've done this before. You just need to simplify them and then do bottoms up. So if I divide by 3, that's going to give me 9 over 2. If I divide by 2, that's going to give me 8 over 3. And now we're going to pull bottoms up to the front. So my final answer is going to be 2v minus 9 and 3v plus 8. All right, that is a monster of a problem, but as long as the only thing that you got stuck in really was picking these two numbers because 432 is so large, that's a minor detail. If you can do everything else, then you should be good for tomorrow. All right, we're on the back here. You can set these up the same way, 4 over 4, but hopefully at some point you're going to start to recognize when you have first numbers and last numbers that are perfect squares. So this is x and x, 2 and 2, and since we have the middle, I don't want to use conjugates. I want whatever I have to be the same. So this is going to be that x plus 2, x plus 2, and we'll just check to make sure that works. 2x, which does give me 4x, so my final answer is going to be x plus 2 squared because they're both the same factor. All right, if we look at 26, very similar. I'm splitting this apart, 3 and 3, 1 and 1, and I guess that's 3x, if that makes you feel better. So I've got 3x plus 1, 3x plus 1. Remember, if this middle sign had been a negative, both of those would have been minus signs, 3x minus 1, 3x minus 1. All right, then we just want to check 3x, that's going to give me 6x, so I know that what I did was right. So my final answer here is 3x plus 1 squared. All right, question 27, similar, but the middle is missing. So I'm going to break this apart, 5 and 5. This time it's -3 and 3 because I have -9. So when I set this up, I have 5 in minus 3, 5 in plus 3, and I'll check. This gives me -15 in and +15 in, which cancel, which is what I wanted. I don't want that middle. Now here you can't simplify the way you're writing that because they're both not the same. So you just have to keep it 5 in minus 3 and 5 in plus 3. Or if you do 5 in plus 3 minus 3, that's fine as long as you have one of each. All right, question 28, similar. 3 in, 3 in. 1 is just -1 in 1. So my final answer is going to be 3 in plus 1, 3n minus 1. And until you feel really confident about what you're doing, you should keep checking that inside-outside section to make sure that it is giving you what you need. All right. Okay, 29 and 30, naming the zeros. Y'all, I'm so sorry, I keep coughing. So you're naming the zeros, which is just the same thing as naming the roots or solutions or x-intercepts. So we're going to do opposite. Remember, if there's a number in the front, it came from the bottom. So this is positive 1/3 and 1/3 0 if we're going to be specific and name it as an ordered pair, which is best. And then negative 1 0. Remember, you're going to do opposite. All right, same on this other side, 1 0. Didn't realize I was giving you similar problems. And then comes from the bottom, so this is negative 1/3 0. All right, rewrite the equations in factored form and then name the roots. So this is really just bringing in those last two skills together, the factoring and the roots at the same time. So you're going to factor. I showed you in another problem that the easiest thing to do here was do GCF first, and here the GCF is actually 3x. So when I divide that out, that leaves me with x plus 10. And I bring my GCF in the front, that's 3x. Since both of these just have like just an x and it's not x squared, I know that I'm done factoring. So I can label, if I want to, which would probably be a good practice, these are the factors. This is what we did in class when we did it before. So now when we name the roots, this one is easy. This is negative 10, 0. This other one, remember, if the x is by itself, just because the 3 is there, it's not going to change anything. The x is by itself. That's a root of 0, 0. All right, question 32. We're going to factor this one out. So again, pull our GCF out first. This time the GCF is just 3. So that's going to leave me with x squared minus 10x plus 25. Again, if you notice the patterns, this is a perfect square, that's x and x. 25 is a perfect square, that's 5 and 5. I want it to give me negative 10, so I'm going to do x minus 5 on both of these. And then if I check that real quick, this is negative 5x, which gives me negative 10. So I know that my factored form is going to be y equals 3 from the GCF, x minus 5, and you can either write it, twice, or you can put the squared, it doesn't matter. And then when we go to name the roots, the 3 doesn't do anything because there's no x there, so it's not part of it. The roots here are going to be 5, 0, and it's really the same thing twice. So I'm just going to label that this is a double root. It's that same root solution 2 times. All right, and then this last question is just a question about what does it look like. So show how 2 real roots, 1 double root, and 2 imaginary roots look different on the graph. So 2 real roots is where I'm going to cross in 2 distinct points on the x-axis. A double root is when the graph and the vertex is on the x-axis. So that root is just going to touch and turn. It's not actually crossing through. And then 2 imaginary roots is where we're not even going to touch the x-axis at all. It's going to cross the y, but it's not crossing the x-axis. So that's going to be your example of 2 imaginary roots. You do need to know the difference between what those 3 look like on a graph.